Okay, yep, another review on the final standard. The square root of 20, not a perfect square, divide into it, and I would hope you would see 20 would divide by 4, okay? So I rewrite that as 4. Well, what 4 times what's 20? 20 divided by 4 would be 5. So that becomes 2, so it's 2 whole square root 5. Okay, now 11. It's not going to divide by anything other than 1. So that's already simplified. Okay. Now the square root of 64. 64 is a perfect square, so that has an answer of 8 whole right on the bat. Okay, now square roots and variables. Okay. So simplify that. So you make your own square root, and first focus on the square root of 125. Remember, it's 125, not 5. 125 is not a perfect square, so we divide into it. So 120, there's no way it divides by 121 or 100. So, whoops, I skipped over 81 here. You need to put an 81 right there if you don't have it, because it goes. Okay, so not 81's not going to work, but 49's a decimal, 36 a decimal, and 25 works, okay? So I rewrite that as 25 times 5. Now remember, these are square roots, so the square root of 25 is 5 whole, and I also have a square root of 5, so I have a 5 out and a 5 in. Now, x to the third. Now, it's to an odd power, so you're definitely going to have an x inside the root, and then you can take 1 away from 3, becomes 2, okay? So that would be x to the 1, okay? You just cut it in half. You can also just put x if it's to the first. Fifth, 5's odd, so you're going to have y inside there, and then take 1 away from that because you already put the y down, and then half of 4 would be 2. And then z to the fourth, that's already even, so I don't have a z inside. I just put z to the second outside, okay? And again, first power, you can just put the variable if you want. Okay, multiplication is the operation. That's a 3-step procedure. They do not have to be the same underneath, okay? So don't underline those. 5 times 6 is 30, and then the square root of 3 times the square root of 6 is the square root of 18. Okay, so we divide our 18 because that's not a perfect square, okay? And it's going to divide by 9, okay? So I drop the whole factor I already have of 30, and I rewrite that as a square root of 9 and the square root of 2. Then I get another whole factor because that's 3, and 30 times 3 is 120, square root 2. Okay, now the addition operation, okay, now they have to be the same, and they are not, okay? So I need to make my table and try to get the numbers underneath to match. So get them, rewrite the equation so that we have like terms. Okay, so 20 divided by 16, nope, divide by 9, nope, 4, okay? So I drop the 2 and rewrite that as 4 and 5. So the square root of 4 is 2 whole. Now you can't forget you already had a 2 whole here. So 2 times 2 is 4. So I rewrite that term as 4 square root 5 plus. Now 320 is not a perfect square either. It doesn't go down to that, but I'm just telling you it's not. Okay. Then you start dividing by 225 is not going to work. Then 196, nope. 144, nope. Or 169, I forgot 169. Okay, nope. 144 didn't work. Okay, you know you can't divide it by 100 because it has to end in 2 zeros to be divided by 100, which it ends in 1 0, but not 2. Okay, then 81, decimal. Okay, so 64 times 5 is how I want to rewrite that. It's got to be like that. So I drop my square roots, and I have 64 and 5. So the square root of 64 is 8 whole. 4 times 8 is 32, square root 5. So I then rewrite that as 32 whole, square root 5. Now I have accomplished and got them to be the same. So the square root of 5 and 4 plus 32 is 36. Okay, now I went out of order. You got to turn to the back side. Okay, the packet I skipped. I'm going to go back to that. Okay, but I want to solve for x and y. I don't want to bring the sine, cosine, tangent in until I have to. Okay, solve for x and y. So you think of this as proportions, but I don't need to use the sine, cosine, tangent, and the OAH. Okay, I know I have a side length of 12 over x and 12 over y. Now again, remember how that works. So a 60, 90, 30, that's a 30 degrees. Sorry, it's not 38. 0 and then the degree sign. Okay, so the hypotenuse is proportional to 2. Okay, across from the 60 is proportional to the square root of 3, and then I have 1 whole. Okay, so 12 is proportional to the square root of 3, and x would be proportional to 2. Okay, and then 12, same thing, square root of 3, and y is proportional to 1. Now this is a little bit dicier here. So you cross multiply 12 by 2, that's 24, divided by the square root of 3. Now again, you can't divide the 24 by the 3 because 24 is whole, 3 is not. Okay, so what you need to do is put square root of 3 on top, and that allows you to eliminate the square root on bottom. So 24 divided by 3 is 8 with a square root of 3 still. Okay, so again, 12 times 1 is 12, and the same thing's going to happen where I can't really divide by the square root of 3. So again, I bring square root of 3 to the top, and then 12 divided by 3 is 4, so y is 4 square root of 3. Okay, likewise on this one. Okay, it's a 45, 45, 90, and those always are proportional. So the hypotenuse is proportional to the square root of 2, and then y and 3 are each proportional to 1. Okay. Okay, so I have 3 over x and 3 over y. So 3 is proportional to 1, x is proportional to square root 2, and then again, 3 is proportional to 1, y is proportional to 1. So here's x. Now I can't multiply that, so I write the expression 3 square root 2, and then divided by 1. Well, 3 divided by 1 is 3, and I'd have square root 2. And then for y, it's easy, okay? You can kind of do it in your head. 3 times 1 is 3, divided by 1 is still 3. Okay, now find the 3 trig ratios of theta. Okay, so again, sine is the O over H, opposite side over the hypotenuse. Here's the adjacent side over the hypotenuse, and then O over A. Okay, so you got to fill those in with values. So the hypotenuse is 17, and then here's my theta, so the O I don't know. And I know the adjacent side's 9. So it's A squared plus O squared equals H squared. So A is 9, 9 to the second. O I don't know. And H is 17 to the second. 9 to the second is 81 plus O to the second. And then I take 17 times 17, or 17 to the second. I got 289. Now, these values are on opposite sides, so I'm going to need to subtract to get the O by itself. So O to the second is 208, and then I find the square root of 208. Okay, 14.42 is my O. Okay, so O, 14.42, H is 17. A, 9, H, 17. O, 14.42, A is 9. Boom, got it. Okay, and then we got to find the 3 sides and the 3 angle measurements. It's called solving the triangle. You already have half of them. You know one side and 2 of the angles. Okay, so the hypotenuse I don't know, so I don't know what that is. And then I reference 46. Oh, get rid of this theta. Get that out of there. That should not be there. Absolutely not. Because you want to use 46 degrees as theta. It's like 46 replaces theta. So O is 14. And then the A, I don't know the A. Okay, so we need to use proportions, but we have to do it in relation to OA and H with the sine, cosine, tangent, because it's not 45, 45, 90. It's darn close, but it's not exact, okay? So again, I put 1, 1, and then the 46 degrees in a parentheses on top. And I got to figure out the A and the H. Okay, I already know the O, so O definitely belongs in each proportion, okay? So A and O's tangent, so tan, and that's OA. H and O is sine, so that's OH. Okay, now replace the O's each in the proportion with 14, okay? And I need to solve for the variable. Now, diagonal from A, I see tan 46, so I put that on bottom, and diagonal from H, I see sine 46. So then I multiply 1 to 14, that's 14, and then 1 to 14 is 14. So, to find the A and the H, we just divide in that order. 14 divided by tan 46, 13.52. And that is my A. Now this H has to be longer than both of them. Not combined, but it has to be longer than either one. Which it is, 19.46. And I got it. Okay, so now my angles, okay. Now these are really close together, the O and the A are, because your 46 and this other angle are close together. You got 90, 46, and then you just subtract those known angles from 180. That's 44. Because that's how many angles are always in any triangle, regardless if it's a right triangle or not. Okay, now we have a nanogon here. It's 9 sides. Okay, so I stick to my trusty S times N times A formula divided by 2. Every side's 10. So the side length is 10, the number of sides is 9, and then the apothem is the trick here. So that's A, and I've split that so that's a side length of 5. As soon as I have 10 up there, I can kind of forget about the fact that it's 10. Okay. Now we are using our proportions, and we do need the 1 and a degrees here. So I got to figure out what degrees. So I take 360 degrees divided by 9 and then divided by 2, okay? Because if you just divide by 9, that's one of these bigger triangles, okay? Because there would be 9 of those. But then I divide by 2 because then there'd be half. It would be half. So 360 divided by 9 divided by 2 is 20 degrees, okay? So 20 degrees. And that's your reference angle is 20. Now again, we got to find the A, and I know the O. I should not have to do anything with the H, okay? So A and O we know is the tangent operation, tangent function. That's OA. Now I have the O value. The O is 5 because we have to find the A. So then 1 times 5 is 5, and then I divide that by tan 20, okay? So 5 divided by tan 20 is 13.74. And that's your A, 13.74. Now you just plug it into this. So you take 10 times 9 times 13.74 divided by 2. 618.3 square feet. Now, again, the reason why that formula works, I know I give it to you, but the reason why is because you know how a triangle, don't draw this, okay? Now you're done writing. But you know how this triangle right here, there'd be 9 of these things, which is why 9's a factor. And then triangle's base times height, base was 10 times the height, which I figured out was 13.74 divided by 2. The 9's there because there'd be 9 of those kinds of triangles within the shape.